Hello, everyone. Welcome to Connecting the Dots, the path from CosmoDB to Neo4j. Today, Murthy, Chandrapaty, and myself, William Liang, we're going to be going over how we evolved and migrated our service, the policy enforcement service, from a document DB to a graph DB. I'll start by doing a quick overview of what data governance is, what our service, the policy enforcement service is. And I'll also cover the performance and scalability issues we had with CosmoDB and how we migrated to Neo4j and the performance improvements we saw from Neo4j. Then I'll hand it over to Murthy to discuss or go over the migration strategy and execution plan. So I'll start by going over what AEP is. AEP is Adobe Experience Platform. This is the platform that customers use to ingest data and drive Adobe Cloud applications such as Journey Optimizer, Real-Time CDP, Customer Journey Analytics, etc. One of the core features of AEP is data governance. Data governance is the framework by which data stewards and data scientists can classify and label data and define usage policy for how that data can be used. The data governance framework then enforces that usage policy by ensuring that data engineers and marketers can create audiences and exercise marketing actions that are in compliance with the usage policy. A core service of data governance is the policy enforcement service. This is the service by which various platform entities are registered and arranged in a label inheritance graph. This label inheritance graph dictates the flow of labels from schemas and data sets down to audiences and marketing actions. And as shown on the screen, you can see how for various customers, this label inheritance graph can get extremely large, extremely complex, and be highly connected. PES was originally implemented in CosmoDB. And as a result, we had a couple of limitations. For starters, in CosmoDB, our data was grouped by logical partitions. And what Cosmo does is it hashes that logical partitions across physical partitions. But what we found in our case is oftentimes, a lot of our logical partition oftentimes got hashed to the same physical partitions. That created a couple problems for us. One, each physical partition is actually has a limit of 10,000 RUs per second, meaning that if one document read consumes 1 RU, we were constrained to 10,000 document reads or 10,000 nodes and relationships per second. The other challenge we saw was that Cosmo doesn't support cross partition transaction, meaning that for us to achieve snapshot isolation, we were constrained to a single physical partition. So CosmoDB being a document DB led us down a path where our data model was entity-centric. So every entity, every node was fully self-contained with respect to its properties. That also led us down to a path where our business logic was optimized for the minority case, meaning that to discover labels and marking action, we had to do a full traversal. The problem with that was that most paths actually didn't result in any meaningful data, so it was a lot of work for no gain. So in migrating and evolving from CosmoDB to Neo4j, that allowed us to evolve our data model from being entity-centric to property-centric. Basically, we were able to explode our data model and factor out the properties as first-class nodes. This allowed us to evolve our business logic from essentially a single monolithic store procedure to a series of very simple Cypher queries. These series of Cypher queries allowed us to essentially optimize for the majority case. So instead of a full brute force traversal, we can go through a series of Boolean-like expressions to determine to find labels, to find marking actions. And this also allows us to short circuit along the way. So instead of a brute force traversal, we simply ask, are labels present, yes or no? Are marking actions present, yes or no? Is there a path between labels and marking actions, yes or no? So if the response was no to any one of those, we can short circuit. If they were all yes, then we knew that we had a violation. So here's some examples of what our queries look like now. Again, instead of a large monolithic store procedure, each of our Cypher queries now encapsulate a very specific part of the business logic. They're all less than 10 lines, very easy to read, very easy to maintain. This allows us to identify issues very quickly. And when we identify an issue, we can fix it very quickly and easily with very minimal risk and dependencies to elsewhere in the code and to other parts, to other queries as well. Let me hand it over to Murthy now to discuss the actual migration.
All right, thanks, William. Hello, everybody. So now, once we have decided, knew that Neo4j was our solution, we faced a different challenge. How do we migrate 84,000 plus customer sandboxes with zero downtime? That was our challenge, and there were some considerations that we did. The API remained unchanged. We still have customers doing or expecting a sub-millisecond policy evaluation requirement, and our data model changing from an entity-centric to a property-centric. So we came up with a four-staged approach for our live migration. We designed this with where T0, or the first step of this, captures a snapshot, which downloads the Cosmos document into a file system in under a second. The T1, or the next stage, is actually the bulk migration, where we actually create the graph in Neo4j. We migrate the data while customers can still process or query the system and keep the writes up. T2 is the key. We replay every change event that happened since the first initial snapshot that we got, and then it actually guarantees the consistency. So T3 is the third stage, or the final step, in which we switch the flag by making Neo4j as a primary database from Cosmos DB. In this architecture, we did the merge queries, or Neo4j's merge queries for idempotency, where we can run safely and rerun it safely as well. This architecture actually helped us to migrate thousands of production sandboxes with zero downtime. So the key of this architecture relies in the change event, how we captured. So every write gets captured into Cosmos DB's change event container, where we store the change events. And during the T2 phase, or forward mirroring to Neo4j, we replay each and every change event that we captured in the exact order. This also gave us the rollback capabilities. If in case any unknowns we want to roll back, this also gave us that capability to roll back to Cosmos DB successfully and without any data loss. The scale that we were talking about is like 13,000 plus orgs or customers, and plus 84,000 plus sandboxes, expecting us a millisecond policy evaluations at a petabyte scale. This was this architecture helped us to do a migration without any downtime. Once we are done, once we have cut over to Neo4j, we saw the latency dropped from 800 milliseconds to 50 milliseconds on an average. The results that we got is query logic simplified. One cipher query traversal replaced multiple document lookups when we used to do it in Cosmos DB. So the data model became very intuitive. New engineers on the team could see the relationships instead of deciphering this JSON references. So our one key insight or critical insight that we got is graph maintenance is fundamentally different from graph traversal. Most graph use cases focus on fast reads, shortest path, relationship queries. Um, our challenge was different. We were write heavy relationship updates across parent child hierarchies, label propagation across entity trees, and real time policy evaluations. So the concurrent write, and on top of that we have the concurrent write across distributed systems. Neo4j gave us the tools we needed. The Cipher merge operations provided idempotent writes. The relationship first storage model optimized for our maintenance workload. Key takeaways are the lessons at first. The zero downtime at enterprise scale is achievable with the event-driven architecture. The change event replace is our consistency guidance. Migrating by complexity, where we ranked some of the sandboxes by the graph's depth, not just by the volume or the data volume. So this gave us got us a ROI faster, where we identified the complex sandboxes which have a complex graph and migrated them first to see our ROI. Graph maintenance, like I mentioned earlier, is different than graph traversal. We are write heavy, and Neo4j helped us to do this or achieve this seamlessly. Um, the journey wasn't just swapping databases. It was rethinking relationships as first-class citizens in our architecture. Once we made that shift, everything else followed. Thank you.